described is attempting to accomplish these harder objectives in the IETF. Right now, of course, we're faced with the same problem we were with construction of interdomain source trees, and that is we need a solution right now. In fact, we needed a solution a year ago. And so one of the proposals that was made by Peter Lofberg was, look, same thing, let's just try and provide a solution right now that will help us in the early stages of scaling up multicast backbones, and that is a proposal to do static allocation that Dave Meyer called GLOP. And the trick at this particular NANOG is for people that try and expand on GLOP, because I don't think anybody to this point knows what GLOP means. The proposal actually is this: temporary allocation of 233/8. Have IANA assign a /8 from the available address space. And then we'll go ahead and statically assign these addresses by mapping in the AS number from a provider into the middle octets of the address space. This approach has been used before. One thing it does is it provides each AS immediately with a /24 worth of address space. And in terms of relevance, right now there's roughly about 150 to 200 active interdomain groups at any time. So if each provider gets a /24, that's actually quite a bit of address space right now. It does two other things. One is it avoids the necessity of doing a registration for addressing, because by definition everybody's already done a registration for their AS. So it increases or decreases the probability that we'll have collision, assuming that everybody participates in this. Now, of course, the proposal is to do this for a one-year time frame, at which point it will be reevaluated as to whether or not other mechanisms in the IETF are available. So one of the things that requires ISP input on this is, what happens at the end of the one-year time frame, and to help participate in that evaluation of whether or not this particular approach should continue. It's proposed that this approach can simply be folded into mask by having mask point to these particular addresses. I think that's a useful way to proceed on this. In general, we need input on what providers believe they'll use mask in MADCAP for, how you'll fold these into the business models for the multicast backbones that you're constructing today. There is the problem in the short term of what happens if you need more than a /24, and of course many people have more than one AS, so the real issue is what happens if you need more than a /24 per AS. All right, and many of you have also described business models that in construction of your current multicast backbones where you're expecting to deploy permanently statically allocated address space. Okay. So it's very important at this point in time that we get operator input into all these particular address allocation issues. Now, of course, in terms of constructing a backbone architecture, the management plane is extremely important, and I'm not going to go into any detail on this. In fact, it might be a good topic for another IETF, or a different presentation. At this point, I'm just going to give a particular example of one requirement that we hear a lot about. So let's say that we've constructed these backbones and we're offering services now. How can we monitor the integrity of a particular multicast tree, ideally before the tree is in production, right, and without accessing a host either at the source or the receiver end? What we'd really like to do is detect a potential fault in that topology and then go ahead and isolate that fault and fix it before there's actually some production session that's in service. And toward this end, Liming-Wei authored a protocol that's now in implementation called the Multicast Reachability Monitor. And it partitions the two tasks by doing fault detection and then some form of classification, so you get an idea about what type of fault may be in existence in a particular topology. In addition, then, by limiting the number of hosts that some subset of that distribution tree, it can actually work on finding the actual system or the region that's problematic, and then theoretically you can work on it. There's two types of components that MRM describes. One is called the manager. The functionality of the manager is to construct a test profile. So let's say that you're selling a multicast service to a professional content provider, and you know where that ingress point to your backbone is going to be, and in fact you know where multiple egress points might be for that particular topology, and you know the group that you could send on or whatever. So the manager constructs that information and then defines which particular routing nodes will be involved in a test of that topology, and then it can signal a start or the stop of that test. In addition, there's a component called the tester. This is typically a router that would originate traffic or sync traffic for the purposes of a particular test. So here's what that looks like in a diagram. If this is our backbone in ISPA, and as I mentioned, here's a source up here, what we want to do is to be able to look at the patency of that particular forwarding backbone. If we identify an MRM manager, now currently an MRM manager there's in a router implementation, so you can do it through a router. But a number of people are looking at implementing the MRM manager on an NMS or workstation or whatever it might be. The manager would send out a test request, and based on the profile of that test, the testers would involve themselves in the test as either a test sender or a test receiver. Test traffic is then generated that would mimic the topology that we would see in the actual production session. And then based on the results, expected results of that, information would be sent back to the MRM manager so that even prior to the test, or in fact, even without having, I don't know how many people have actually set up things like NANOG or IETF or interop or whatever, but one of the common things is you get the circuit, you can get a termination router in, but they won't allow you access to set up the LAN. Well, it'd be nice if you can go ahead and work on the topology, right, before, at least work on the backbone information before you have access to all the platforms. And so this is one of the things that allow you to do. All right, let me talk just briefly about deployment status then. So we know PIM sparse mode's been in operational use for over 4 years, and MBGP and MSTP now for over a year. Of course, GLOP and MRM are new proposals. They're just in implementation within the last month or so. We really see about 35 ASs originating AS messages. At this point in time, we're still in the early deployment of MSTP, so many ASs are representing the origination of these SA messages for other ASs. About 125 ASs in the MBGP topology and about 2,000 prefixes in the MBGP specific routing tables. So it's a long ways from 50,000, but I think if we think about the fact that these are highly aggregated addresses, we can see that there's a significant increase in hosts that are represented in this routing table even over just a year ago. As I mentioned, there's more and more public exchanges now, in addition to the initial 3 that I described. And you know, a point that Bill pointed out is a lot more people are looking at you know, point-to-point peering as well as doing public exchanges. So, in terms of traffic activity, we're seeing you know, on the average of about 150 to 200 active groups in the interdomain space right now, and about 50 to 20 megabits of non-redundant traffic at an exchange like Ames Research Center, which tends to be ground zero for the internet multicast right now. Probably more important in this, though, I think, is the fact that we're now seeing regular streams in excess, certainly of 500K, but more and more people are sourcing multicast with MPEG-1 streams in the interdomain space. And I think that's important because, and it's possible as well because of the fact that people are taking PIM, MBGP, and MSTP now, and they're constructing these multicast backbones on top of some of the technologies that we talked about yesterday, so the high-speed backbone technologies. Right? As a result, the sourcing of a 1 megabit stream in multicast is an insignificant issue, really, compared to the fact, you know, say even just 1 year ago. But even closer to that, we're seeing examples that I'd like to sort of close out on here. The one that was done a couple of weeks ago by Ames Research Center. We had a project called Virtual Collaborative Clinic, and in this project from the Biocomputational Center over at Ames, the objective was to be able to take real-time 3D medical imagery and to use a tool called a cutting tool, which is really like a virtual surgical tool. They can go ahead and cut out sections of these 3D medical images real-time. All right. Now, the objective was to distribute this information to remote sites so that they could participate in the evaluation of this biomedical image at the same time. Of course, this application generates 25 to 50 megabits of unique traffic. So there's almost no way to accomplish this to any number of distant sites at all without using the inherent capabilities of multicast, right? One packet per link. Now, even just a couple of weeks ago, in fact, this wouldn't have been possible, or certainly a couple of months ago. But I think the fact that networks like NRIN, as well as some of their peering networks, Abilene and Calrin, have deployed PIM, MBGP, and MSDP on their new high-speed infrastructures. And as a result, not only was NASA able to distribute this information inside their own network, but they were able to get it out to remote sites using the interdomain space. So they got it to Stanford and UCSC, remote site out at Shiprock, New Mexico, using unidirectional link. So I think this is an example of the fact that these new backbones are allowing applications that we wouldn't have seen even a few months ago to take advantage of multicast. Well, let me summarize. First point is the interdomain multicast is still a hard problem, and it's still actively being worked on in the IETF. Okay, so we don't have the long-term solution, but I think that's no excuse for looking at the fact that we also do have a solution for deploying production backbones for the amount of state that we have in the internet right now, doing that right now, using PIM, MBGP, and MSDP. Randy brings up an absolutely critical point, and I think a point that we need to keep in front of us as a main focus over the next half a year to a year, and that is we absolutely need to make multicast easier to deploy and support. It has to be logical. When you approach it in the router, you have to be able to logically understand it so that you can troubleshoot it. And I think both from vendor implementations as well as protocol, we need to address that. But in addition, I think a lot of that is, I mean, we have to look and face the fact we've got like generations of unicast internet experience available. And in terms of multicast, the equivalent amount of multicast experience, we can probably count the number of people on one hand that have that same amount of multicast experience. So what we really need is more operational experience. And certainly, whatever direction we go on, we need to continued input from the ISP community. Thanks.
We have time for a few questions.
Questions?
I see someone not wearing a tie-dye T-shirt.
This is not Bill Fenner.
Hi. Actually,
Get the mic on in just a second.
Microphone. 3, 2. Hey. I'm not wearing a tie-dye, but I am still Bill Fenner. I just wanted to ask about the use of PIM version 2. Is there anyone using PIM version 2? And do you still have to use version 1 compatibility mode to play in the Big Eye Internet multicast stuff?
No, based on the protocols that I've described here, I mean, certainly there's implementation of PIM version 1 and PIM version 2, at least in Cisco. It's possible to set up PIM through whatever mechanism in the interdomain in your backbone and still participate in this particular approach using MSDP and MBGP in the interdomain space.
But for example, if you're peering with the PIM version 1 domain, then you have to use PIM version 1 somehow on that border, or is there something else that's going to happen?
Well, by default, what'll happen is it'll default to the lowest common denominator. So right now, the routers will use PIM version 1 sparse mode in the interdomain, or if both routers are capable of handling it, it'll use PIM version 2.
Okay. For those who don't keep up with these things, PIM version 2 is what's trying to be standardized in the IETF, and PIM version 1 isn't really even pretty much documented anywhere. So if you're not Cisco and you want to implement PIM version 1, you have to try to figure it out. I mean, that's why I'm kind of worried about the requirement to use PIM version 1 to play in the sandbox right now.
No, actually there is no requirement to use PIM version 1 to do what we're doing today. By default, maybe John wants to add something to this here.
Now, I use PIM version 1, PIM version 2 all the time, right? And basically 12.0 in Cisco iOS is PIM version 2. The only difference between running PIM version 1 and version 2 is whether or not you use AutoRP. And Cisco recommends using AutoRP because my experience, I do the testing on it all the time. My experience is the use of a bootstrap router is a pain in the butt trying to figure out how to make that work and being able to do scoping of RP information so that you can limit where you're going to have your RPs and how far your multicast groups are going to be distributed, and setting up all kinds of different domain boundaries. You find it a lot easier to do that with AutoRP, at least currently. So as far as running PIM version 1 and PIM version 2, it doesn't really matter. Sparse mode works because it just sends up a PIM version 1 router may not understand all of the information, but I've never had any problem with running PIM version 1 and PIM version 2 simultaneously. And as far as 11 whatever, since forever, PIM version 1 and PIM version 2 have been working for a long, long time. So there is no problem in that regard, or that's my experience.
Okay, so you're saying that someone who's running PIM version 2 in their domain pretty much has to depend, if they have, say, a router implementation that has PIM version 2 only because they haven't figured out what PIM version 1 does since there's no spec for it, they're dependent on their neighbor's border router to convert into PIM version 1 if that's necessary. So they're dependent on their interdomain neighbor being a PIM version 1/2 speaker. This is a rat hole, never mind.
Yeah, I think the real issue, Bill, is that right now we see people doing PIM version 1 and PIM version 2. It hasn't been problematic in terms of construction of these. Okay, any other questions? Okay, lunch.
well,
Thank you very much.
Yeah, that was great.